Today we are moving right along in Chapter 5, and we are on Chapter 5.5 now. And today we're going to start talking about dividing by decimals. How is that different than what we've been doing? Stuart?
We've been dividing a decimal by a whole number, and now we're using a decimal in the divisor and the decimal in the divider.
Sure. So we've been working with the divisor as being a whole number, right? We've been dividing decimals by whole numbers. And now we're going to take it one step further and see what happens and see how we can divide when we divide by a decimal. Okay, so your learning goal for today is to be able to model division by decimals. What do we know we're going to be doing today if it says that our learning goal is model division by decimals? Liam? We're going to be drawing pictures, and is our divisor going to be a whole number or a decimal? Clarissa?
The divisor is going to be a whole number.
If we're dividing by decimals, we're going to be dividing by a decimal, which means our divisor is a decimal. Yeah. But first, let's take a look at the problem of the day. It says Lisa is making reusable shopping bags. That's very good of her, right? Like, you know how when you go to the grocery store now, you don't get free paper or plastic bags anymore? You have to use those reusable ones. Otherwise, you have to pay 10 cents, right? So Lisa doesn't want to pay 10 cents, so she is making reusable shopping bags. She has 3.6 yards of fabric. She needs a 0.3 or 3/10 yards of fabric for each bag. How many shopping bags can she make from the 3.6 yards of fabric? All right, what is the question asking? Siddharth, what is the question asking?
Asking how many shopping bags can she make from the 3.6 yards of fabric?
How many shopping bags can she make from the 3.6 yards of fabric? What is the important information we need to solve this problem? Adam?
That she has 3.6 yards of fabric.
Altogether, okay.
And she needs 0.3 yards of fabric for one bag.
Okay, so let's see if we can model this problem. Okay, so you see here that you have some 10 by 10 squares. Go ahead and draw yourself, I would say, 4 10 by 10 squares. Count them in your notebook and draw them out. Let's shade in an amount that would represent the total amount of fabric that Lisa has. How much fabric does Lisa have altogether? Yarded? 3.6 yards. So how could I model 3.6? What do I need to color in lightly? We're going to color lightly in this case. What do I need to color in? Ariel? 3 whole boxes to represent the holes. Okay, go ahead and just, you don't need to do it very detailed, just color it really quickly. 3 whole boxes to represent the 3 holes. And I have 6/10 left over, so how can I model 6/10? Arushi?
You color in 3 rods and then 6 rods.
6 rods. Okay, go ahead and do that. Color in 3 holes and 6/10 or 6 rods. Okay, so as you can see, it has quickly colored in 6/10 by coloring the 6 rods over here, and she has 3 holes. Would you agree that this is 3.6? Yeah. Now, Lisa needs to take this 3.6 and make reusable shopping bags. How much does she need for each shopping bag? Siddharth? And what would 0.3 yards look like in a quick picture? Liam? 3 rods. So she could take these 3 rods right here and use them to make one shopping bag, right? Go ahead and circle that. Circle 3 rods and say that that's one shopping bag. Does she have any more fabric left over that she could use to make another shopping bag? Okay, let's make a second shopping bag. How many rods would it take to make another shopping bag? 3 rods? Okay, go ahead and circle 3 more rods. Does she have any more fabric? Does she have enough to make another shopping bag? Okay, let's mark off another 3 rods that she's going to use to make her third shopping bag. How many rods do I have left in this one? 1. So does she have still enough to make another shopping bag?
She does.
Yes.
She does, but there's only 1 left.
Because she has another.
Oh, she has more fabric. Okay, so does she have enough to make another shopping bag? We said yes, right? So there's 1. And then how many of the ones over here do I need to mark off? 2. Okay, so let me do that. So there's going to be 1 and 2 over here. Does she still have enough to make more shopping bags? Okay, so go ahead and mark off groups of 3/10 until she doesn't have any more. Daniel, how many groups of 3/10 did you find that would fit into 3.6? 12 groups. Let's go ahead and let me count too. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 groups of 0.3 of 3/10 in 3.6. Another way you could say that is 3.6 divided by 0.3 is 12. Or 3.6, divided by 0.3 is how many groups? 12 groups. So how many reusable shopping bags can Lisa make with her 3.6 yards of fabric? 12 bags. Julie has $1.75 in nickels. How much money does she have? Okay, does it matter that it's in nickels? No. Okay. How many stacks of 25 cents can she make from $1.75? Okay, so let's model it. Let's shade in the total amount. What's the total amount of money she has? What's the total amount of money she has? Claire? $1.75. So draw yourself 2 boxes, because it's going to take you 2 boxes to model $1.75. Matthew has colored in 1 whole square to represent what? 1 whole. Then he colored in 7 rods going this way, or he colored in the other way, but I rotated it. 7 rods represents what amount?
70 cents.
Or 7/10 of a dollar, right? And then he colored in 5 squares to represent the 5/100 or the 5 cents. Very good. Now we want to group this into groups that are how big? 25 cents. So what would I need to circle in order to circle one group of 25 cents? What would I need to circle? Rashika?
So I didn't exactly circle, but I already know it because the 75 cents, like $1.75 and 25 cents are benchmark numbers.
But I'm asking you, what would I need to circle to model it?
2 rods and 5 cubes.
Okay, so I'm going to circle a group that's 2 rods big, as well as 5 cubes. So here's my 2 rods. I'm going to count 1, 2, 3, 4, 5 cubes. So my group is going to be like this. That's my first group of 25 cents. Do I have room for more groups of 25 cents?
Yes.
Yeah, okay. So my second group would also be 5/10, 5/100, and then 2 rods. Okay. Go ahead and circle groups of 25/100 and see how many groups you can find in the total of $1.75. Jason, please model it on your paper. Zara, how many groups did you find? 7 groups. So what does that tell us? It tells us if we share $1.75 equally, and I want to find groups that are 25/100 big, or 25 cents big, how many groups are there? 7. You can see that here's a problem, 1.2 divided by 0.3. They've drawn you a model. They drew 1.2. Would you agree that this is 1.2?
Yes.
And then they circled groups that are how big? How much is in each group? 3/10. Why did they put 3/10 in each group? Why did they put 3/10 in each group? Adriana?
Because the divisor is 3/10.
Because the divisor is 3/10, there needs to be 3/10 in each group. How do I find the quotient? How would I solve this problem? Neha? The quotient is always the number of groups. So how many groups are there? 4. So therefore, 1.2 divided by 0.3 must be 4. All right, let's take a look down here. They've modeled the dividend. 0.96 or 96 hundredths is right here, right? How do you know really quickly without counting each little square that this is 96 hundredths? Liam?
96 hundredths is 4 hundredths plus than 1 flat, and 4 hundredths are not shaded in.
Right, so you can see really quickly that there are only 4 hundredths that are not shaded in, so this must equal 96 hundredths. Would you agree? Yeah. So they took the dividend and they split it into groups. How much is in each group? How much is in each group? Shreya?
2400.
Right, and you can see that there's 2 rods and 4 unit cubes shaded in, which means that's 24 hundredths. Why did they decide to put 24 hundredths into each group? Siddharth? Because the divisor is 24 hundredths. So how can I find the answer? 96 hundredths divided by 24 hundredths equals, Daniel?
It equals 4.
How did you know it equals 4?
Because I counted the 4 groups.
I saw that there's 1, 2, 3, 4 groups. Excellent.